Hello everyone, welcome to today's class of Pharmaceutical Organic Chemistry, which is arranged by Dr. APJ Abdul Kalam Technical University. I am Rosalind Mishra, Assistant Professor, ITS College of Pharmacy. In today's class, we shall be looking into various topics related to carboxylic acids, aliphatic carboxylic acids. Now, before proceeding into today's class per se, let us just have a brief glance about this unit of carboxylic acids, okay, the various topics which are included in this unit. So, according to this, carboxylic acids or aliphatic carboxylic acids has been divided into various heads, namely acidity of carboxylic acids. We shall be learning about the effect of substituents on acidity, about inductive effect, qualitative tests for carboxylic acids, amides, esters, about structures and uses. That is, today's class we shall be dealing with structures and uses of various acids. For example, acetic acid, lactic acid, tartaric acid, citric acid, succinic acids, oxalic acid, salicylic acids, benzoic acids, benzyl benzoates, dimethyl phthalates, methyl salicylate and acetyl salicylic acids. Okay. So, moving on to the chapter. Structure, the first derivative of carboxylic acid is acetic acid. Okay. Now, the structure of acetic acid is CH3 COOH, CH3COOH, which can also be written as CH3CO twice H or molecular formula C2H4O2. Molecular formula, it has a molecular formula of C2H4O2. Next, when undiluted, it is sometimes also called as glacial acetic acid. Okay. So, acetic acid when undiluted is also known as glacial acetic acid. Vinegar is roughly 3 to 9% of acetic acid. Vinegar is a very common household item which is used in the kitchen, mostly used in the Chinese cuisine. This vinegar is roughly 3 to 9% acetic acid by volume, making acetic acid the main component of vinegar apart from water. Okay. Acetic acid has a distinctive sour taste and a pungent smell in addition to household vinegar. Okay. So, acetic acid has a carbon which is attached to 3 hydrogen atoms, which is in turn linked to a carbonyl group. This carbonyl carbon is attached to hydroxyl group or hydroxyl oxygen. Okay. Now, understanding the structure further, the carbon hydrogen has a bond angle of 109.5 degrees, whereas the carbon and the carbonyl oxygen has a bond angle of 120 degrees. The carbon and the hydroxyl oxygen has a bond angle of 105 degrees. Okay. Next, these are the major contributors for the reaction of acetic acid. These are the minor contributors. So, here if we can see the parent acetic acid or the parent acid and parent base or water molecule, when acetic acid is placed in an aqueous solution, then the conjugate acid is formed H3O plus and the conjugate base gets produced CH3COO minus. So, when acetic acid is placed in water, then the resulting product which is formed is a mixture of a conjugate acid and a conjugate base. Okay. So, the conjugate acid in this case is H3O plus and the conjugate base in this case is CH3COO minus. COO minus. Okay. So, we get a mixture of compound when a parent acid reacts with a parent base, a mixture of conjugate acid and a base is formed which is hydronium ion and carboxylate ion, hydronium ion and carboxylate ion. So, the IUPAC name of acetic acid or of carboxylic acid is acetic acid. Other names, acetic acid is also known as ethanoic acid, it is also known as vinegar when diluted, it is also known as hydrogen acetate, also called as methane carboxylic acid. Okay. Now, the chemical formula of acetic acid is C2H4O2. This is the chemical formula of acetic acid. Now, the molar mass of acetic acid is 60.05 gram per mole. Acetic acid has a molar mass of 60.05 gram per mole. Acetic acid is colorless liquid. Okay. It is a colorless liquid. It has a pungent odor or a vinegar like odor. Acetic acid has a boiling point of 118 degrees to 119 degrees Celsius. It has a boiling point of 118 to 119 degrees Celsius. Okay. It has a density of 1.049 gram per centimeter cube. The solubility in water, if we talk about acetic acid, is it is miscible in water. Acetic acid is thoroughly miscible in water. It has an acidity or pKa value of 4.76. It has a pKa value of 4.76. So, all of you, with the help of this table, you can see that we have described various properties of acetic acid, starting from the IUPAC name to common names. We have also looked into the chemical formula, molar mass, appearance, odor or the physical properties, density, boiling point, its solubility and acidity of acetic acid. Now, let us look into the uses of acetic acid. Well, acetic acid is used as industrial chemical. It is used primarily in the production of cellulose acetate, namely for photographic films. They are used for making polyvinyl acetate, they are used for making wooden glue and synthetic fibers and fabrics. Acetic acid is the major ester, or the major esters of acetic acids are commonly used as solvents for inks, paints and coatings. In household, dilute acetic acid is often used as descaling agents. Okay. So, dilute acetic acid is also used as descaling agents. In the food industry, acetic acid is used as a food additive. Okay. So, these are added to the food as additives. While talking about medicinal uses, how can we forget acetic acid injection into the tumor has been used to treat cancer since the 1800s. While diluted acetic acid is used in iontophoresis reactions, it is also used as treatments for otitis externa. It is an effective antiseptic when used as a 1% solution with a very broad spectrum of activity against organisms such as streptococci, staphylococci, pseudomonas and enterococcal organisms. Okay. So, with this we have learnt about the structure, various properties and uses of acetic acid. The most important ones which we should never forget are the medicinal uses, namely acetic acid injections, which has a treatment effect for cancer, diluted acetic acid and its use and its application in iontophoresis, its treatment as otitis externa, and also we should not forget its beneficial effect as an antiseptic, because this compound is active against a huge spectrum of bacteria, starting from gram positive to gram negative, namely streptococci, staphylococci, pseudomonas, enterococci, etc. Moving on further, structure and uses of lactic acid. Okay. So, lactic acid is another derivative of acetic acid. This is again another derivative of acetic acid. Lactic acid is an organic compound with the formula CH3CHOH, CH3CHOH. In its solid state, lactic acid when solid, it is white and water soluble, whereas in its liquid state, it is colorless. Okay. It is produced both naturally and synthetically. With a hydroxyl group adjacent to the carboxyl group, lactic acid is classified as an alpha hydroxy acids. Okay. These belong to the category of alpha hydroxy acids, because the hydroxyl group lies just adjacent to the carboxylic group. In the form of its conjugate base, it is called as lactate. It plays a very important role in a number of biochemical processes and a number of biochemical reactions. So, this is the structure of lactic acid. Okay. D and L forms lactic acid, and this is lactate, wherein the hydrogen atom is removed, forming carboxylate ion. Lactic acid is also known as milk acid. It is also known as milk acid. It has a chemical formula of C3H6O3. It has a molar mass of 90.08 grams per mole. It has an appearance of colorless crystalline form in nature. It has a melting point of 53 degrees Celsius. It is soluble in water. It has a pKa of 3.86. Okay. So, these are the various properties of lactic acid. Lactic acid, also known as milk acid, which is produced from milk. The most important use of lactic acid, or the most important benefit of lactic acid, is its being an alpha hydroxy acid. Now, let us look into the various uses of lactic acid, how it is used in pharmaceutical and cosmetic preparations. Lactic acid is employed in pharmaceutical technology to produce water soluble lactates. Okay. It is used in pharmaceutical technologies to produce water soluble lactates from otherwise insoluble active ingredients. It is used in topical preparations and cosmetics to adjust acidity, and it is also used for its disinfectant ability and keratolytic properties. Lactic acid is also used as a buffer. Okay. So, from this we can easily understand that lactic acid is a very important, has got a very important role in pharmaceutical technology. Okay. It is because it can produce water soluble lactates from insoluble active ingredients. It is used in topical preparations or the upper preparations in cosmetics, and it is also useful in adjusting the acidity. Apart from all these uses, lactic acid also has disinfectant benefit. It can also be used as a disinfectant. It is also used as a buffer. Now, lactic acid, apart from being a very important pharmaceutical and cosmetic additive, it has got a wide range of use in the food industry. Okay. So, when we delve into it further, lactic acid can be used in meat, poultry and fish in the form of sodium and potassium lactate to extend its shelf life. So, it is used as a preservative in the poultry and meat industry to increase the shelf life of the produce. They have the ability to control pathogenic bacteria. Because of its mild taste, lactic acid is used as an acidity regulator in beverages such as soft drinks and fruit juices. So, apart from being used as a preservative, lactic acid is also used as a acidity regulator. It is because of its mild taste, very mild smell and taste, it is used as an acidic regulator in food industry, mainly in the preparations of beverages and fruit juices. Lactic acid is effective in preventing the spoilage of food such as canned olives, gherkins, pearl onions and other vegetables preserved in brine. So, basically these are used as preservatives which prevents the food material or the canned food material from spoilage, namely olives, gherkins, pearl onions and other vegetables. Lactic acid may also be used as a preservative in salads and dressings, resulting in product with milder flavor while maintaining its microbial stability and safety. Okay. So, in food industry, as we can see, lactic acid has got a huge role. It acts as a preservative, it acts as a disinfectant, it acts as a acidity regulator. It also, because of its mild taste, it has got a wide range of use. It can be used in a number of, it can be used for preserving a number of food items. Okay. Also, it is a good descaler. Okay. Lactic acid is a good descaler. It removes soap, scum and it is a registered antibacterial agent. Lactic acid is also used as a mosquito lure. Lactic acid along with ammonium bicarbonate is used in the Lurex brand mosquito attractant. Okay. Apart from this, various applications of lactate preparation can be seen here in the table. Buffered lactic acid is used in hard and soft candies, in the preparation of hard and soft candies. Calcium lactate is used for making toothpaste, mouthwashes and chewing gums. Ethyl lactate is used as a flavoring agent in strawberry and butter. Ethyl lactate is also used as a pesticide. It is also used in hair care treatments, in making hair care treatments such as shampoo. Lactic acid is used as a wound dressing. It is used as acidity regulators in jellies and ice creams. Zinc lactate or lactic acid preparation in the form of zinc lactate is used in oral care for making toothpaste and mouthwashes. Lactic acid preparation in the form of sodium and potassium lactate is used for making cakes, breads, rolls, fresh meat, pancake and bread. So, here in one single table we have listed down the various preparations of lactic acid and their uses or applications. Okay. Next, moving on further, tartaric acid. Tartaric acid is another derivative of acetic acid or another derivative of carboxylic acid. Tartaric acid is a white crystalline organic acid that occurs naturally in many fruits, most notably in grapes. It is also found in bananas, tamarinds and citrus fruits. Its salt, which is potassium bitartarate, which is commonly known as cream of tartar. It is commonly mixed with sodium bicarbonate and is sold as baking powder. It is used as a leavening agent in food preparation. Okay. The acid itself is added to food as an antioxidant in order to impart distinctive sour taste. Okay. So, what are the various uses of tartaric acid? Tartaric acid is a white crystalline organic acid that occurs naturally in many fruits, most notably in grapes. It is also found in bananas, tamarinds and citrus fruits. Its salt, mainly potassium bitartrate, commonly known as cream of tartar, is very commonly known or widely known. It is mixed with sodium bicarbonate. Tartaric acid is mixed with sodium bicarbonate and is sold as a baking powder or used as a leavening agent in food preparation. The acid itself is added to food as an antioxidant and to impart its distinctive sour taste. So, this is the molecular formula or the molecular structure of tartaric acid. The D and L forms of tartaric acids are given here, and this is the meso form of tartaric acids. The IUPAC name of tartaric acid is 2,3-dihydroxybutandioic acid. 2,3-dihydroxybutandioic acid. Tartaric acid is also known as threaric acid, racemic acid, uvic acid and para-tartaric acid. These are the various names of tartaric acids. This is the chemical formula of tartaric acid. It has got a molar mass of 150.087 gram per mole. It is a white powder. It has a melting point of 171 to 174 degrees Celsius. It is soluble in water and has an acidity of 2.89. The pKa value of tartaric acid is 2.89. Moving on to the uses of tartaric acid. It is used as anti-scorbutic acid and an antiseptic. It has been used in the production of effervescent salts in combination with citric acid to improve the taste of oral medications. Tartaric acid is a great source of antioxidants. Another health benefit of tartaric acid is that it aids in digestion and fights flatulence. It improves intestinal absorption as well, which will increase the rate at which healthy nutrients flow into our blood stream. One of the most surprising benefits of tartaric acid is that it significantly improves glucose tolerance. Now, salt of tartaric acids like potassium sodium tartarate, also known as Rochely salt, which is used as saline cathartic. Moving on to citric acid. Citric acid is a polyprotic acid and are capable of donating more than one proton. Okay. Citric acid is a weak organic acid that has the chemical formula of C6H8O7. As I told you, tartaric acid is a polyprotic acid. Okay. So, it has the tendency or an ability to donate more than one proton atom. Okay. Hence, polyprotic acid, hence the name polyprotic acid. Citric acid has 3 ionizable protons, which we can see here. It has got 3 ionizable protons, which it can donate. It occurs naturally in citrus fruits. Biochemistry wise, if we see, then it is used as an intermediate in the citric acid cycle, which occurs in the metabolism of all aerobic organisms. In citric acid, the middle acid group that has the lowest pKa, this is because the hydroxyl group also bonded to the middle carbon is electron withdrawing by induction, and a negative charge associated with the conjugate base will be stabilized to the greatest extent on the middle carboxylate. Here, with the help of this table, we have tried to brief down various characteristics of citric acid in terms of appearance, melting point and solubility. The chemical formula of citric acid is C6H8O7. It is soluble in water, alcohol, ether, ethyl acetate and DMSO. Citric acid powder is used as a food preservative when added to beverages and pharmaceutical products. It has a tangy taste which makes it applicable as a flavoring ingredient for candy and beverages. It is also an antioxidant, hence making it favorable for addition into products used in skin care products. Citric acid is a type of alpha hydroxy acid. okay, making it a good agent to remove dead skin cells and exfoliate the skin. It is important for producing energy that keeps us active. Biochemically, it is important for producing energy that keeps us active and healthy and is safe for human consumption. Also, its alkaline nature helps to balance the acid levels in our body. It is used in the canning process as it helps in maintaining a healthy pH balance inside the food and helps to prevent botulism. Again, it is used as a preservative. Citric acid can also be used as mouth rinse as it removes bad odor. Citric acid combined with other ingredient can make up a very good anti-aging mask. Again, this is because of its AHA property, alpha hydroxy acid property. Citric acid has alkalizing properties which helps to bind calcium and therefore preventing the formation of kidney stones. It also helps to keep the kidneys in a proper functioning form. So, with this we finish up our topic of aliphatic carboxylic acid. Here we have the references. Thank you all. Stay safe. Hope our chapters were of use to you all. Please make good use of these videos. Do watch them. Thank you.